Hello once again. As usual, I'm very happy to have all of you back. Today we're going to work on the power cord coming into this Bakelite block. There are two capacitors in there. Both of them are connected on one side to ground. So that means we're going to have one cap lead that runs from here to ground, and the other cap lead will run the other side of the second cap rather will run also to ground. So it would be one lead here, and the other two leads both connected to ground inside that block. I'm just going to, again, take out what's in there. These are very important because those two caps inside that block are in the power line. I don't want to take any chances. We're going to get them out of there. And right now, later on I'm going to pick up some Y1 X2 caps, I think they're called. I talked to my mentor Brendan about that, and he said you really should be using those. I never did buy any of those. The next order I put in with just radios, I'm going to buy some of those Y1 X2s. I've always just bought either X2 or Y2, and that's what I have on hand. But temporarily, in order to power the radio up and check it, I'm just going to go ahead and put these types of caps, 0.015, on the outside of the block. And hopefully I'll be able to get a cap order in the not too distant future, and then I'll take them off and put the Y1 X2 caps in their place. Anyway, today what we're going to do is take this fuse holder, and I'm going to mount it down in here. I'm going to glue it in, and I'm going to use my newfound really good stuff, JB Quick. No more waiting, 10, 12 hours for that stuff to harden up. Now with the JB Quick, I tell you what, it hardens up in no time. 4 minutes to set. And it is 4 minutes, like I said. And then about an hour later, that stuff's like a rock, so it won't go anywhere. So first we'll go ahead and put in the fuse holder. And, you can use any kind of fuse holder you want. You don't have to use the kind I use. Some people just mount a fuse holder like this on a terminal strip and then put the fuse in that way, or they buy the inline kind, where you unscrew the two halves and the fuse falls out. I happen to like these. These are kind of my favorite. I'm used to using them and they work well. Won't be long, we'll be firing up the radio, but we are not going to hurry, we are not going to rush. Many times I've stated when you get to the point where you're almost ready to put the power to it, that's when you need to slow down. Slow down. Don't go fast, because that's when you start making mistakes. In particular, right now, when I'm messing with this power line, Bakelite block, and what's inside there. I'm going to take it out. I'm going to go ahead and remove all that crap. Then I'm going to put the new caps on the outside, like I said. I could just go ahead and unsolder them and jam the wires all the way down through the hole, through the rivet holes, down there in the center. I can jam them way down in there, but I don't know. Like I said, this radio's going to someone else. I want to take no chances. No chances. All right. Let me go ahead and now what I did. Wait a minute. Let me tell you what I did before I start gluing here. I just took the back of the fuse holder and I ran it across this really coarse sandpaper like that a little bit. Got it nice and roughed up. Okay, you want a nice roughed up surface for the glue to adhere to. Then I took the let me see. I took the old emery cloth. You can do this with a moto tool. That's how I normally do it, but I figured I'd show you a little different way here. Nice coarse emery paper is all this is. You just kind of rough it. I marked out with a pencil. You can see the two lines in there that I marked out. I set the fuse holder in, just marked out. I'm just going to rough it up between them a little bit because I want them to, I want the glue to have a good rough surface to adhere to. You got to kind of like take your time, just kind of sand it and get it pretty rough. Okay, it's no big deal. You don't have to rough it up completely, just about, maybe 2/3 of it and you're good to go. All right, now I'll just go ahead and mix up the cement. I'll put the cement down in here, then just set that right down in there on top of there, and then just let her dry. Now when you put these fuse holders in, be careful you don't interfere with the screws that hold the chassis to the cabinet, okay? If I stick that fuse holder way over here in the corner, it'd be right in the way. When I run the chassis screw up through the bottom of the wooden radio cabinet, I'd hit it. Gotta always be thinking on this stuff. Always be thinking. Well, the next block is clean. Got everything out. Unfortunately, one of these capacitors we took out had a number on it. I was kind of glad to see that. I wanted you to see it. This one is 19. That's the way they usually have a number on, just like that. This one here does not. Maybe they just fade off. It had a little band around it right here. The other one did, but I don't know if that's a part of a number. I don't see any number on that thing whatsoever. Anyway, that's what they look like. You know, even the wider ones used to have numbers on it. It'd be 10, 15, whatever. I guess 19 stands for 0.015 microfarads. Incidentally, just to show you which block I just opened up, it's this one right here. This is the power cord coming in on both sides of the block. We have two 0.015 microfarad capacitors that are grounded in the center. Okay? That's the block I just cleaned out. The two caps have been temporarily attached to the outside of this block where the power cord comes in. I'll be reconnecting that pretty soon. We're going to connect one end here, and then we're going to run the rest through a fuse, through a resistor, or through a fuse through a resistor, and then back down. The other end will connect into here, and we'll go through all that. And I'll show you how the switch is wired in and everything. The switch wiring is over here, comes all the way across, winds up right here. We'll go through all that when the time comes. But right now, I was going to put a 20 ohm 25 watt resistor here, but unfortunately this radio has 11 tubes, which is about twice anything I've done yet, and it draws over an amp of current, so I can't use a 20 ohm resistor. I can use it can be 25 watts, probably 10 watts would work, but you know, 25 would be best. And so I need to cut down on the size of the resistor from 20 down to 10. Well, it's a new day. Let me tell you what I did since yesterday. I've ordered a 10 ohm 25 watt aluminum cased power resistor. Now this one here was the one I was originally going to put in, and it's a 20 ohm. It won't focus. Well, it doesn't matter. This was a 20 ohm 25 watt. I ordered a couple of 10 ohms, and when it comes in, I'll be putting it right there like that, okay, right after the fuse holder. However, I dug around in my stash, you know, so as not to delay the turn on of this radio. I dug around in my stash and I came up with a 10 watt 8 ohm. Now 10 watts, you know, Brendan did some calculations for me, and you know, it actually needs a 12 watt minimum, but a 10 watt will work for a temporary turn on and check out. It's going to run a little bit high. Now what I intend to do is place it, if possible, right up against the casing of the, you know, the chassis itself, and that'll help bring the heat down a little bit. But it would take quite a while before it would actually burn out, and but it will get hotter than usual. So let's hope it can withstand it with no problem. I'm going to go ahead and mount that on this terminal strip like so. We'll just go ahead and mount that on there like that, and then put the terminal strip up there, and then when the resistor comes in, we'll trade it out, okay? The power cord has been wired in. Now it comes in, you know, it's a dual line power cord, you know, two-sided cord. One end goes to one end of the fuse. It'll go through the fuse. It'll go through the 8 ohm resistor. It'll come out this red wire. Now this terminal board and this resistor is just temporary. So is this red wire. Yeah, I don't know. We may use the red wire over. Anyway, it comes down and it connects to right here, which is one end of this capacitor, which is going to become a safety cap, and then it goes from there to ground. Okay. Now the other side of the power cord right here comes straight up and goes to this connector, which goes through the capacitor to ground. Now on the schematic, this is what we're talking about. This little squiggly on top right here is actually supposed to be the fuse. It didn't turn out that way, but anyway, this is the fuse and this is the resistor, okay, that I added. You come in, you go through the fuse, through the resistor, on over to the switch. Well, no, I didn't see a switch connection, did you? Yes, I did. I'm going to show you. After it comes out of the resistor, it comes down to here. Like I said, it goes through this cap to ground, but it also goes out this black and white striped wire. Yeah. That black and white striped wire goes all the way over to guess where? The switch back up in there. That's right, ladies and gentlemen, the switch. The other side of that power line comes in and comes up and solders to right here, where this capacitor, which will be another safety capacitor, it goes over to ground. But it also has a wire coming off it right here. See there? That's the white wire. And that white wire comes across and goes into the power transformer. Then it comes out this one, goes over to the switch. Then it comes out off the switch, that black and white wire. The black and white wire comes across, comes here, up through the fuse, down, the resistor, down through the fuse, and out to the plug. Oh, isn't that easy? Now keep in mind, when you look at your schematic, you won't exactly see that because the schematic is showing two windings. If you'll remember, way back when, we determined this thing only had one winding, so it's going to come from the plug down to the one side of that capacitor, which goes to ground. Then from here, it's going to go into the winding, through the winding, come out of the winding, come over to one side of the switch. And then from that side, the opposite side of the switch, it's going to come across, up through the fuse, the resistor, up through the fuse, and out to the return. All right, let's go ahead and jump this fuse holder. Since I don't have a fuse in it right now, we'll go ahead and jump that with an alligator wire. And I've got the multimeter connected to the plug. And we're going to find out whether or not this switch will turn on the whole thing or not. I've got my multimeter set up here. Here we go. Well, there it is, 16.3 ohms. Okay, now that includes, the winding of the power transformer. It includes the 8 ohms here and the other associated wire and the leads on the multimeter. Not bad. So we know everything is wired right. The switch works. Good to go. The last two things I want to talk about before wrapping up this video, someone asked, should I put a 3-wire power cord on these radios, or can I just leave the 2-wire? Well, let me tell you the facts of life on that one. You're never going to get agreement on that. You're never going to find a total consensus on whether or not you should use 2 or 3-wire power cord. I even bothered to check with, I always say leave the 2-wire. And I said, I better check with my buddy Brendan on that, my old mentor up there in Detroit, see what he says. He says the same thing. Don't worry about it. Just leave the 2 wires. It'll work fine. Unless you're working on an AA5 radio. An AA5 radio has no power transformer. You might want to put a, there's a couple of things involved with that. Best thing to do, I'm not going to confuse you between the AA5 and this radio here that has a power transformer, So I say leave the 2 wires and connect them in accordance with the schematic. Use new wire and a new plug, of course. Don't. Now I'm going to go ahead and use the original wire. It's not really the original wire. It's a wire that somebody replaced. And I'm going to go ahead and use it for the initial power up. But later on, we're going to put nice cloth covered wire on here with a nice brand new plug. That's my answer for that. And to find out more about the AA5 business, where there's no power transformer in the radio, become a member on the Antique Radio Forum and use their search function. Too many people get on that Antique Radio Forum and they start asking question after question after question, questions that have been asked 1,000 times. All they have to do is search the subject they're looking for. Up at the top is a link for search. You type in the information you want, do your search, and you'll find 1,000 different links that'll pop up within the Antique Radio Forum itself. And you can click on and read the threads, the past threads, all about the subject you're looking for. Okay? All right. Now, the next thing I'm going to talk about is determining the size of this resistor right here to cut down on the incoming power. I know there's a lot of questions about, well, how do you determine that? How did you figure that out? And how do you know that a 20 ohm is too high and you went ahead and ordered a 10 ohm and you know that that's going to be okay? How do you know all that? Well, we'll cover that and then we'll call this video over. Listed on the paperwork that I got from Chuck Schwark are the electrical specs. And according to this, at 115 volts supplied to the radio, the consumption would be 130 watts. So let's divide, the formula would be dividing the voltage into the watts to find out what the current draw is of this radio. Alright, we've got 130 watts. Let me see, divided by 115. That will equal 1.13 amps. Well, now that we know the current draw based on the specs, if I were to put a 20 ohm resistor in here, what would be the voltage drop across the 20 ohm resistor? If I took 1.13 amps and multiplied it times what I wanted to put in there originally, which is a 20 ohm resistor. Let's see what that works out at. Alright, we got 1.13, let me see, it'll be times 20 ohms. Okay, the voltage drop across that 20 ohm resistor would be 22.6. Okay, now if I have 100, my power coming from my wall is 125 volts. So 125 volts minus 22.6, that means I've got 102, a little over 102 volts to run that radio. No good, can't do that. We have to cut down that 20 ohms. Cut it down to 10. Alright, let's try that again now with 10 ohm, with a 10 ohm resistor. We got 1.13 amps times 10 ohms. 11.3, that's the voltage drop across that resistor at 10 ohms. Now 11.3, so we'll round it off at 11. 11 volts from 125 is about 114 volts. Now 114 volts is what we're looking for to operate that radio. Alright, the last thing I'll leave you with, there's always a lot of questions about what size fuse do you put in the, in the radios. How do you fuse them? I've seen this asked on the Antique Radio Forum of many different guys, many different people asking many others. You will not get a consensus on that. You get all kinds of answers. Let me give you an example. Now this radio will have what's called surge voltage. Everything you turn on has an instant surge. Bam! Okay? And if the fuse is too weak to hold it, boom, it'll blow the fuse. There's just nothing you can do about it. My Variac on my bench, my red one, it's a 3 amp Variac, but every time I turned it on, the fuse blew. And I'm thinking, oh my God, I got a defective Variac right after I first got it. Well, not so. I stuck a 4 amp fuse in it, and I have not had a single trouble with that Variac since, and it's been years, okay? The surge voltage was knocking out the fuse. So what I like to do, now this is going to carry, we already know it's going to carry 1.13 amps or thereabouts. So I think what I'm going to do is put either a 1.5 or a 1 3/4. And if that, and if surge voltage blows the fuse, then I'll kick it up to 2. But I always like to go 50% above. If it requires 1, go to 1.5. If that's not quite right, take it up in quarter increments, I think. Anyway, there again, it's a judgment call. Call it like you see it. Oh, and fast blow fuses, don't go with the slow blow. If this thing gets a big surge, I want that fuse to blow. I want this transformer protected. Fast blow. Well, that's it. Next time we're going to finish up all the little details and before the turn on. Thanks for being here once more. Until next time, this is John.